Okay, now looking at some exam style questions for our bounds topic. We're first told that a rectangle has a length of 21 centimeters to the nearest centimeter and a width of 4.3 centimeters to the nearest millimeter. We now need to work out the upper bound for the perimeter of the rectangle. So first things first, I like to draw out my shape just to see what I'm working with. So we have 21 centimeters as our length and 5.3 centimeters as our width. Okay, so now we are told that 21 centimeters is measured to the nearest centimeter. So we put 21 centimeters on our timeline or our error interval timeline. We then, because it's to the nearest centimeter, we add one on the right hand side and take one away on the left hand side. And I'm talking about with regards to 21 in this case. We then draw our two midpoints from 20 to 21 first, which is going to be 20.5 centimeters. Then from 21 to 22, we get this upper bound to be 21.5 centimeters. This is our lower bound. This is our upper bound. And in this case, we're told to work out the upper bound for the perimeter of the triangle. So we're interested in this value. Okay. Now, looking at our width, we are told the width of the rectangle is 5.3 centimeters. I'm going to convert this into millimeters because the question refers to it or talks about it that is to the nearest millimeter. So I think for simplicity reasons, 53 millimeters is more suitable. Because it's to the nearest millimeter, we add a millimeter to it on the right hand side to put this as 54. And on the left hand side, we take one away from 53 to get 52 millimeters. Once again, using our midpoints, we get this to be 52.5 millimeters and this side to be 53.5 millimeters. Once again, we're interested in the upper bound. So I'm going to convert this back into centimeters, which is going to be 5.35 centimeters. Now, we can draw our rectangle, or sorry, not redraw, but we can change our rectangle to represent the upper bound values for this. So our upper bound for the length was 21.5 centimeters, and our upper bound for our width is 5.35 centimeters. Now to work out the perimeter, remember these two sides are equal in length and these two sides are equal in length. Therefore, we're going to have 21.5 add 21.5, add 5.35, add 5.35. This is going to give us a value of 53.7 centimeters as the upper bound for the perimeter of our rectangle. So now we need to work out the lower bound for the area of the rectangle. So we're going to have to use the lower bound for our length times by our width's lower bound. And if you remember, I know I've rubbed them out, but our lower bound for our length was 20.5 and our width lower bound was 5.25. So to get the lower bound for the area, remember the area of the rectangle is worked out by doing length times by width. So using our lower bound corresponding values, we're going to get our answer to be 107.625 centimeters squared. Okay, looking at the next question, it tells us that a circle has a radius of 5.36 centimeters, correct to 2 decimal places. We're told to work out the lower bound for the circumference of the circle. Remember, our circumference of the circle is given by 2 times by pi times by r. First of all, we're going to have to draw our error interval timeline to get 5.36 centimeters in the middle. Then what we're going to do is we notice that it's correct to 2 decimal places, right? So we notice that the last value is 6, so it is in the third position or in the second position after the decimal point, right? So what we're going to do is we're going to push that up by 1 in the positive direction. And what I mean by this is put it as 5.37 centimeters. So as you can see, where the last value was of 6, we've added 1 on the right hand side, and then we're going to drop it by 1 on the left hand side to get 5.35 on this side. So we can now use our same method to work out our midpoint to be 5.355 centimeters and our above midpoint to be 5.365 centimeters. Now, remember we're told to work out the lower bound for the circumference of the circle. So using our lower bound value, we're going to get 2 times by pi times by 5.355. Now, this is going to give us an answer of 33.65 centimeters. We're now told to work out the upper bound for the area of the circle. The area of the circle, remember, is given by the formula pi times by r squared. Plug in our value for the upper bound of the radius. We're going to get 5 times by 5.365. And remember, the radius is squared, so it's going to look something like that. This is going to give us a final answer of 90.4 centimeters squared. Okay, looking at a slightly more difficult question, we're told that f is given by this formula here, and g is equal to 12.7 correct to 3 significant figures, and h is given by 9.294 corrected to 3 decimal places. We need to first consider our bounds and work out the value of f to a suitable degree of accuracy. And when we are told to work something out to a suitable degree of accuracy, this must mean we must conduct our lower bound and our upper bound value for f, and we're going to have to see where the digits are common and write that out. And I know that might seem a bit confusing, but watch, we're going to get into it and it's going to be very simple. So our lower bound for f will be given by a lower bound for g and an upper bound of h. And this is a very difficult concept to get your head around. I completely understand. But if we're to think about it, a smaller number on top, say 10, divided by a big number on the bottom, the biggest possible number, say 20, is going to give us an overall smaller value for f. And therefore, this is why our value for f is the lower bound. So say if I was to flip this around and work out the upper bound for f, we're going to get f is equal to the upper bound for g and the lower bound of h. Now imagine the upper bound of this was 20 and the lower bound for h was 10. We're going to get a bigger number overall for our value of f. So we're going to use the different bounds of g and h to manipulate a situation where we can get the lower bound of f and the upper bound of f. So we're going to have to first consider our bounds for g. So looking at g, we're told that 12.7 is rounded to 3 significant figures. So we have to look at the third figure in this case. That's going to be 1, 2, and 3. 7 is going to be our third significant figure. We then alter that value and increase it by 1 increment on the right hand side and decrease it by 1 increment on the left hand side. That's not centimeters. So we now need to consider our midpoints. Our left hand side midpoint is going to be 12.65 and our right hand side midpoint is going to be 12.75. So now let's conduct our bounds of h. So our h bounds, we know that 9.294 is going to be our middle term. Then looking at our third decimal point is 4. On the right hand side, we're going to increase that value by 1. And on the left hand side, we're going to decrease that value by 1. Remember, that is to do with the middle value of 2.294, sorry, so 2.293. Now we're going to consider our midpoints. And we're going to get this side to be 9.9, 2.29, sorry, I keep making that mistake, and 9.2945. Okay, now remember what we said. Our lower bound for f is given by the lower bound of g and the upper bound divided by the upper bound of h. So the lower bound of f is going to be given by the upper value for g divided by the lower value for h. Because remember, a bigger number in the numerator divided by a smaller number in the denominator will always give a larger value for whatever we're trying to work out. And in this case, we're trying to work out f. So it's going to be the square root of our upper bound of g. So square root of 12.75 divided by our lower bound for h, which is going to be 9.2935. And in this case, we're going to get our value to be 0.38421,63037. And in this case, it's very integral to write out the full decimal form. Okay, now working out the upper bound, for f. Oh no, I did work out the upper bound. That's supposed to be upper bound. Sorry, guys. This is now the lower bound of f. So we're gonna have to first work out a lower value for g divided by an upper value for h. Because remember, guys, a lower number on top divided by a larger number on the bottom will give us a lower number overall. So this is going to look something like the square root of 12.65 divided by 9.2945. And this answer is going to be 0.382665431. Now remember when I said we're going to have to look at the common values in the decimal form, in the full decimal form, between lower bound and upper bound to work it out to a suitable degree of accuracy. As we can see, the 0 is common, the 0.3 is common, the 0.8 is common, but after that point, they begin to change. Therefore, our answer to a suitable degree of accuracy is 0.38. So, this is our final answer. Okay guys, that's going to conclude today's video on exam style questions. As always, please make sure to like, comment and subscribe, and I'll catch you guys in the next video. Peace.